Hey, hi everyone. Thanks for joining me on this workshop. So this is a Kong Mesh workshop. We will talk about service mesh architecture. That is one of the products that Kong is doing. Kong is not only an API gateway, like the most popular one, it's also a service mesh and also an ingress controller and many more features to come in the future. So today the topic is how to deploy a service mesh on multiple clusters. And I will be your host. So I'm Baptiste Collard. I'm working as a technical account manager with Kong. And I like to speak about everything Envoy or web security, right? So, and the agenda for today is a big picture of what Kong Mesh is. I will also try to explain some typical patterns we see with our customers when it's about maybe multi-cluster, multi-tenancy, or multi-mesh. What does that mean? Then I will go with a demo, and then I'll talk about additional enterprise capabilities we have. So first thing is Kong Mesh. For people who don't know what a service mesh is or what's its purpose, so basically, I think you all know what a gateway is, API gateway is. That's typically to secure access to your APIs. You can have that at the edge of your infrastructure. Also, you can have some internal API gateways between platforms or between line of businesses, for instance. But when it comes to in-app connectivity, like connectivity between microservices, then the best pattern to adopt is maybe a service mesh. So this is the key. Why a service mesh? So basically, there are three well-known pillars for service mesh. First, it will help developers to accelerate in their release cycles because they will be able to delegate some concerns to the platform, like everything resiliency when it's about client load balancing, failover, retries, and these kind of things. They can absolutely just describe the way it should behave between the services. Typically, they will use Kubernetes CRDs to do that. And then the service mesh platform will take over and implement these kind of resiliency features. The second aspect is about security. So service mesh is a great platform to implement network policies between two services. And you can easily implement this zero trust architecture in an easy way. Typically, what we see customers do is start easy, then they will probably start allowing access between two different namespaces, and then they can do some more fine-grained policies for policy-to-policy access. And the third pillar is about observability, because with the service mesh deployed, you will easily have metrics exposed for each service in the mesh, and also traces, logs, and all of that in a standardized way. So this avoids confusion when you have multiple ways of formatting your logs for each application. When you have this handled by the service mesh, then it's really easier to aggregate all this information, the logs and the metrics. Right. Now I would like to clarify some, I would say, different patterns of service mesh. We often hear the question, what's the difference between a multi-cluster architecture and a multi-mesh architecture? So just talking about frequency, I would say that we most often see companies using an hybrid cloud approach or multi-cloud approach. That's why they will basically use a multi-cluster architecture with their service mesh platform. So typically, that by configuring a root CA, root certificate, that will help them federate the identities of all the workloads deployed on all the different clusters. And since they all have this same root CA, they will be able to implement this kind of service-to-service access policies, right? The second thing we see a bit less often is multi-tenancy. So this is where when the company act as a SaaS or PaaS platform operator, and in this case they have their own tenants, and you basically want to isolate all your tenants' workloads into separate zones, let's say. And to do that, again, a service mesh will be really helpful, because an easy approach, again, is to leverage the Kubernetes namespaces to isolate those workloads. And this is something you can easily do. And most often, the platform operator will also expose centralized services or shared services to all the tenants. And again, with a service mesh, it's quite easy to set up some access control policies, in the sense of you can set up some tiering. So let's say a given tenant is working under a silver subscription, so they can use your shared services, like maybe 100 requests per minute, but the gold subscription would allow them to use these same shared services, like with 1,000 requests per minute, right? And the last thing we sometimes see is multi-mesh. So in this case, this is really for, I would say, really large companies where they have really different business units or line of businesses, and they work in different business, I would say, different parts of the companies. They have no interaction at all. So in this case, it can be a good model to have them using different meshes, and these services will never talk together. If they want to do that, they will go through an internal or an enterprise API gateway. So the multi-mesh thing is more for, I would say, yes, stronger isolation of all the workloads belonging to a given business unit. Right, that's for the differences of service mesh deployments. And now, why Kong Mesh? Why I'm talking about Kong Mesh today? Because from experience, I can tell that Kong Mesh is really easy to get started with. It's easy to deploy, easy to operate, easy to understand, because all the policies, all the CRDs are, I would say, policy driven. So once you start reading the CRD, it's quite obvious how you can configure it and tinker with it. Second thing is you can absolutely deploy Kong Mesh the same way onto Kubernetes and also on VMs. And third thing is that Kong Mesh was designed to be multi-zone native and also multi-mesh native, which makes it really more, I would say, easy, or again, like a good fit for multi-cloud architectures. Cool. So Kong Mesh itself is one of the enterprise products we have at Kong. It's based on top of Kuma, which is an open source project that was given to the CNCF a couple of years ago, like as you can see, 2019. And we are building on top of that. What's really nice with Kuma is that even in this open source version of the product, you will already find nice capabilities like, again, multi-zone, multi-mesh, and all the policies, basically, except maybe one or two of them. So talking about architecture, Kuma itself is based on Envoy for the sidecar part, or for the proxy part. And obviously, it makes it really fast and dynamic in terms of configuration and traffic routing and throughput, right? And as you can see, Matt Klein also said that was a good option to use Envoy as a building block of a service mesh platform. Same story with Kelsey Hightower, who also had kind words regarding Kuma, because it demonstrates how easy it can be to use a service mesh. Well, now, if we take a big picture of the typical architecture you will have with Kong Mesh, you will find a global control plane that will somehow manage all the zonal control plane onto each cluster, right? So these zonal control planes will first discover the services, but also enforce the policies to the envoy sidecars running next to your workloads, right? And once the services are discovered, they will be pushed to the global control plane and then distributed among the zonal clusters. So this is also a good choice in terms of resiliency. If you have one of them that's down, that's not an issue as long as Envoy is configured. It will just be an issue if you want to enforce new policies. And also, like many other service mesh platforms, Kong Mesh comes with some ingress capabilities. First, to allow for east-west traffic between your clusters, and also with a built-in gateway. So there is a lightweight gateway that comes with a couple of policies like open policy agent or rate limiting, global rate limiting. And since this built-in gateway is based on Envoy, you can also use our proxy template to leverage existing Envoy capabilities like maybe today JOT validation, because this capability exists in Envoy but is not yet exposed in a particular Kong Mesh CRD or Kuma CRD. That would be something like Mesh JOT. It's on the roadmap, but just to say that you can actually hack the gateway because it's based on Envoy. Cool. So that's for the architecture. As you can see, what we generally see is clients use their enterprise gateway either at the edge of their infrastructure or maybe as an internal API gateway. Then they route the traffic to built-in gateways and then to their services. You can absolutely reuse an existing gateway at the edge of your infrastructure as an ingress system, or eventually if you have an existing ingress controller, you can also reuse it, and you are not required to use that built-in gateway. So there is just a quick configuration to set on your service representing your gateway so that the traffic can come in, and then MTLS is enforced between your gateway and the services. Great, so I will skip that one because I think there is not much to add. And just before jumping into the demo, I would like to summarize what I've just explained. So Kuma/Kong Mesh is multi-cluster native, multi-mesh native. It's also compliant with the gateway API architecture, so let's say. Also, we are actively contributing both to the gateway API interest groups, as well as the sub-project that's called Gamma, which is a way for standardizing the traffic inside a service mesh. So we're trying to stick to this approach. Also, what's nice with Kong Mesh as an enterprise product is that it can easily integrate with external CA systems like Cert Manager, AWS Secret Manager, and also Vault, for instance. You can easily deploy Kong Mesh onto VMs, even Kuma. We also embrace the OpenTelemetry architecture. And as you have just seen, we integrate with any API gateway if you want so. Great. I think that's already a lot in terms of background and context. So now let's move to the demo. So the demo today will use 3 different clusters. One cluster where the global control plane will be deployed, Kong Mesh global control plane. A second cluster that's called West, where we will have a zonal control plane, and a third cluster called East with, again, a zonal control plane. Then the application itself that we will use for the demo will be spread onto those 2 clusters. So the front end will be on one cluster, cluster West, and basically the 3 versions of the backend V0, V1, V2 will be on the other cluster, as well as the databases, Redis and Postgre. And just for fun, we will also deploy one version of the backend on the first cluster, and backend version 0. And then we will play with traffic routing. Great. So let me move to the demo part. I hope I didn't miss anything important. If you want to know more about the differences between Kongmesh and Kuma, you will find it easily on our documentation website. As you can see here, it's mostly about integration with external CA system. Also, we have particular builds for compliance. We have support for Open Policy Agent in Kongmesh. Well, great points. The airbag system. We have an advanced airbag system in Kongmesh, which really makes sense if you don't want to give the ability to all the developers or all your teams to configure the mesh. Maybe you just want to restrict them to particular namespaces or services when they enforce policies. So if I take a look at our webpage about airbag, what you will see is, I guess, an example of, yes, this is basically a role where we can say, okay, for these policies, I want to scope them down to these sources and this destination. You see, so you can easily enforce, yes, exactly, role-based access control to your users of the service mesh platform. Great. Quick break. Sorry about that. I'm back, so let's resume. Great. So let's move to the demo part. What I start doing is to deploy the Kongmesh global control plane on the first global cluster. So I have actually already done that. It literally starts here, as you can see, global control plane. What I have done so far is adding my Helm repository to my Helm configuration. And then I switch to my global cluster. I have created a particular namespace for Kongmesh. I am using my Kongmesh license, but for today, everything I will show is possible as well with the open source version of Kongmesh, which is Kuma, as you have understood. And then what I will do, I will just use a few values for my Helm chart. So the key point here is I will deploy Kuma with the mode set to global, because I want first to deploy my global control plane. I will need my services to be of type load balancer. I'm using this my license key, and then I have Helm installed my Kongmesh chart with those values, and that's pretty much it. So I've just done that before the demo starts, because sometimes it can take a few minutes to get a public IP address. So I hope that's ready now. Yes, good. Now I have a public IP address. So next thing I'll do, I'll configure my Kuma CTL command line so that it will help me later on when I will want to register my zonal control planes. So to do that, I will just copy and paste this command, kumactl config control plane. I will add my global control plane with a particular name. That's all good. And now we also get another external IP address exposed by the global control plane that will be used by the zonal control plane to synchronize the configuration and these kind of things. So now we'll move to the first or next cluster. I will use my kumactl command that I have just configured before to generate a new zone token. That's not a mandatory step, it's just a good practice in terms of security, so that you can actually double check which zone are going to register with your global control plane. So let's get a new token for my first zone, right? I got that. And now, same story. I will create a new namespace. I will create a new secret with my zone token. I will create Helm values, but this time I will set the mode of Kuma to zone instead of global. And I will tip my zonal control plane with the address of the global control plane, right? And then you will find a few options like, yes, the token that I'm using to register that zone, again, the license. And also there are two more options here. I will enable the ingress so that I can have cross-cluster traffic, and why not the egress pod so that I would be able to control traffic exiting the cluster to external services. And this way I would be able to enforce either traffic permissions, rate limiting, and this kind of things. And last step will be to, again, create a secret with the license and Helm install my zonal control plane. So let's run all these commands on my first zonal cluster. I hope I didn't miss any step. And while it's working, I will do the same thing on cluster 2. Again, I will fetch a new zonal token, place it into a secret, prepare my Helm values, and Helm install cluster 2. So let's wait a bit. And then we will head over the Kong Manager, which is a read-only web UI, where you can see the status of your mesh or meshes if you have several meshes. And also you can check which policies are applied to which services. So it's really nice and convenient. So back to my terminal, I will install the second cluster. And while it's running, I will start port forwarding to my global control plane web UI and see what's going on. I think I can do that on another terminal. So yes, just let me open that new window in a window you can all see. All right, good. Oh, there is a new version of Kong Mesh, great. So this is the manager web UI where I can right now see one zone, but I should see two in a few minutes. Apidays-west is ready as a zone. Also, I should be able to find a mesh, and I will talk about that in a minute, a bit more, and also the airbag system I've mentioned before. So let's refresh it and see if everything is fine with the second zone. Well, we're seeing the second zone appearing. It's offline right now. Let's wait for it to be alive or ready. Looks good. And yes, I can see my default mesh. So what is my default mesh? Let's move back to the configuration. As I have explained before, Kuma is designed to be multi-mesh aware. So by default, there is a default mesh, but I could have more. I just need more custom resources with kind mesh. And in this case, for this default mesh, well, the next step for me is to enable MTLS so that the connections between the services are secured and each service connecting to another service is somehow authenticated. So there are several options here. For demo purpose, I will use the built-in system to generate automatically have Kuma generate a root CA for me. And from that CA, it will generate client certificates for each of my workloads, right? But I could also use other options like integration with Vault or AWS or Cert Manager, for instance, right? So I will just apply that mesh custom resource on my global cluster. And with that, I should see mesh enabled on my web UI. So now if I come back to my web UI, what I can see is my two zones, one mesh. No services are deployed or in the mesh now because I didn't tag any of them with a mesh label, one sec. Sorry about that. And in the default mesh, I can now see that MTLS is somehow enabled with the built-in module, right? But no workloads are part of the mesh right now because I cannot see any service or any data plane proxy, which are the sidecars, right? So let's fix that. Or just before, we will also enable access logs. And as you can see now, and you will see with maybe all the policies I will use today, and they all have the same form. So the point is all my service mesh policies will use a target so that you tip or you tell Kuma where this particular policy should apply. So in this case, I want to apply my mesh access log policy to all the mesh, okay? But basically, I could use subsets like a particular zone, a particular namespace, a particular service, and these kind of things. So that's really, really powerful. So I will apply my mesh access logs to all the mesh so that I can extend the demo log format that's used by Kuma. And in my case, I'm adding this upstream cluster envoy log command just because it's helpful sometimes. So let's apply this policy. Looks good. And now I will deploy my demo application. So these YAML resources are just a set of deployments and services as I have shown in the big picture. I will show it again while it's deploying. Okay, so as you can see, it's creating a bunch of services and deployments. And just for you to remember what I'm doing, I'm deploying in a new namespace called demo that I will label with sidecar injection. I'm deploying the front end and back end on one cluster, and also back end with different versions on the second cluster, and also Redis and Postgre databases. Great. So let's double check the status of these pods. So kdemo is an alias for kubectl-n from namespace demo. So my frontend is ready, one of the backend pod is ready on cluster 1, and on cluster 2, I will run the same command, and we can see that the backend versions are ready. Also, the PostgreSQL and Redis instances are running. All good so far. And as you can see, 2 on 2 means that there are 2 containers that are ready. So the application itself and also the sidecar that will capture all the inbound traffic and the outbound traffic to enforce our policies. Right. Let's get back to the script. So what I want to do now is take another look at my web UI, my Kong Mesh web UI. If I head over to Mesh, now what I can see is Kuma has found 4 services across the clusters, but in the default mesh, right? So that's something that is already nice. And for that backend services, it has found 4 data plane proxies, basically 4 pods, right? If I click that backend demo application and then I click data plane proxies, I will see that 3 pods are running on cluster east and 1 pod is running on cluster west. So what just happened here is global service discovery enter the game. So basically, each zonal control plane has discovered the services that are part of the mesh and pushed the information to the global control plane. That's really, as you can see, it was very easy to do. Great. So next part for me is to do some to check if the application is working correctly, obviously. So to do that, I will port forward to the front-end application and try to load the page. Again, it has loaded in another window. Sorry about that. But let's open the window here. So port forwarded to the front end. As you can see, I can load the web page, and this is a kind of e-commerce website with different articles that I can add to my cart. And so the front end is calling the back end, which will query the PostgreSQL database with all the articles, and also it will query Redis to get the ratings, the stars for that particular article, right? So as you can see, we already have the cross-cluster traffic working, because front end again is on cluster 1 or cluster west, and the backend and databases are running on the other cluster. So everything is running fine so far. If I reload the web page, sometimes I can see another version of that web page with a promotion. That means that I'm hitting now backend version 1, and backend version 2 comes with 2 different promotions. So if I want to finally manage how frontend is connecting to the different versions of the backend, I will use a mesh HTTP route policy. But just before doing that, what I will do, I will just quickly show you what the built-in gateway looks like. So to do that, I will create new resources. One of them is mesh gateway instance, which represents an envoy instance, basically. Let's say it this way. So I will create a new gateway on cluster 1, a built-in gateway, right? All good. And I think I deleted, yes, the snippet. Then I will select that gateway, and I will add a listener to envoy on port 80. So let's do it again. Everything should be quite quick. And last step is to create a gateway route. So in this case, I want to match all the routes, all the queries starting with / and send the traffic to that particular backend, which is my front-end application. So I will run that, and hopefully I should be able to hit the service that's on top of my envoy built-in gateway. So if I go to cluster 1, k get services in all namespaces, because I'm not sure where I've deployed that built-in gateway. So that's called Edge Gateway 3. So if I use that IP address in my browser, I should have the same result. All right, so far so good. So again, I'm refreshing the web page, and sometimes I'm hitting another version of the backend. Great. So that was just to show you how easy it is to configure the built-in gateway. So now what I will do is play with the traffic split. I will use a new policy, mesh HTTP route, and again, I want to select where I want to apply this policy. So I want to apply some traffic split onto my front end when it's going to the backend, right? And in this case, for all the requests, so all the HTTP requests starting with /, I want to send half of the traffic to version 1 and the other half of the traffic to version 2. So let's run it and see what happens. Now I'm going back to my web page and reloading the page. So as you can see, sometimes there is one version of the page with 1 promotion and another version of the page with 2 promotions, which means this is version 2 of the backend. So as you can see, it was really easy to configure. And basically, all the policies are that easy to configure and to understand, right? Last part of the demo, I will move to the security part, to the zero trust part, but only with a level 4 policy, just to enforce a policy where front-end cannot anymore access the backends, but I could use level 7 policies, or in the sense of I could say my front-end can access the backend only with GET request, but not with HTTP POST request. You see, so let's start easily with an easy example. the first thing I need to do is to clean up all the policies that I have in this cluster, and I will use that new mesh traffic permission CRD. And again, I want to apply that that policy to all the mesh. When it comes from all the mesh, oh, wait, my bad. I just want to allow, this is a default traffic permission to allow the traffic to work between the services in the mesh. And now I will use a traffic permission, another one, where I will target a subset of my services. So basically, for all the services in the second zone, when the traffic comes from the front end, I will deny the traffic. So obviously, if I run this, I apply this policy, and if I refresh the web page, I should see an error at some point, unless we have the demo effect. So let me double check. Created, deleted. Let's give it some more time. Not yet. That should be immediate. So there is a small glitch here. Too bad. Sorry about that. We should see a 500 error, like the front end saying, okay, I cannot access the backend. Sorry about that. Okay, I won't waste time debugging that because the timing is short. And just a last try. No, okay. Sorry about that. Okay. So next step in my demo was to show you maybe the observability part. We have a shortcut to help you deploy all the observability stack with Kuma CTL. So if you run this particular command, Kuma CTL install observability, it will generate Kubernetes manifest to deploy Grafana, Prometheus, and these kind of things to have a nice dashboard pre-configured to observe all the traffic going through your service mesh. But since it can take some time, I have prepared a few screenshots down there. So let me move back to full screen. As you can see, you will be able to see metrics for each control plane, either the global control plane or each zonal control plane. Also metrics for each data plane, which are the proxies. So you can see all the traffic coming in and out your services. Same story for the full mesh. You can see global metrics for the mesh health. We also provide dashboards for service-to-service communication. This one is for a particular service, and this is what you get when you use another dashboard called Kuma Mesh. You have this nice service map graph that helps you show the traffic between your services, even if they are spread onto multiple clusters. Also, we can help you set up some Grafana alerts, and we also provide dashboards if you're a Datadog user, as you can see. Great. Back to the slides. I think I skipped one part. So just a few words about Connect. So Connect is our SaaS version of the global control plane, be it with the gateway part, the API gateway part, where we can configure and manage the control plane of your API gateway, or also we can manage the control plane of your service mesh. It's super helpful if you don't want to waste time and money operating your control planes. And also, what's really nice, this is another view of what I'm talking about. So the Kong Connect control plane will help you operate all your products. So the API gateway, the Kong ingress controller, and also Kong mesh as a service mesh platform. With that, what becomes interesting that you have, yes, I have a screenshot, is you Connect will be aware of all the APIs you are managing in your API gateway. Also, as you have understood, it will be aware of all the services that were discovered across your clusters or zones. And what becomes interesting, sorry, is you can start composing your APIs as a product. So for instance, you can say, okay, that particular service in this cluster, which is part of the mesh, and also that other service, basically not APIs, but if I put them together, maybe I can think of them as an API now. So of course, you will be able to select particular services in the mesh, but also particular operations of existing APIs, and you will be able to compose an API as a product. So it's really powerful. Yeah, you can just try it out. If you go to cloud.connecthq.com, you can create an account for free and start exploring all the capabilities of Connect. Really a good story there. So I think that's all for me today. I will leave you with a few takeaways. As you have seen, deploying Kuma or Kongmesh is really easy, and it's using the right building blocks. It's multi-cluster native, multi-mesh native, compliant with the standards like Gateway API and Gamma. It integrates with external services or cloud services that you will typically use in an enterprise context. It works well with the OpenTelemetry stack, and as I have explained again, it works with other API gateways. Thanks for watching, and thank you.